right, so the other thing is on this is to be sure to know when we do start using our calculators and when you see something that's just a log, base 10 is what's understood. Like when you have x, 1 in front is understood and the exponent of 1 is understood. Same thing with log base 10. Whenever you have a base 10, you always want to just write it, or you'll see it like this. You won't ever see the base actually there. The 10 is understood for log. So eventually we'll change that depending on what calculator you have. Some of your calculators let you put the little number there. If you have an older calculator, you just have to use a change of base formula, but both of them will work. The same is true for the natural logs. Whenever you have natural log, the base is considered to be e. So log base e always needs to be written as natural log. Natural logs don't ever have a base. Okay, they won't have anything other than it kind of is automatically the base of e. So log of x, if you're ever writing a log, you don't put the 10. It's like writing your answer of 3/1. It's not wrong, it's just not simplified. Same thing with log base e. Log base e should always be written as natural log, and you should never have an e there. Now, when you're doing your work, if you need to put it there to kind of as a placeholder to remind yourself, then do that. It's just your final answer should always be completely simplified. Also with natural logs, anytime there's an e involved, it's always going to be a natural log. Okay, so anytime there's an e in the problem, right now we're just going to do some evaluating, simplifying, solving, but when we get into the word problems, again, whenever there's an e, that's the only time that you're always going to use natural log, because that is the automatic base for the natural log. And then there's also a log button on your calculator and a natural log button on your calculator that will, if you don't know where it is, we'll talk about that next week. Here are some properties that you can remember. You don't necessarily have to know these properties. You can use your go from log to exponential and exponential to log to get these answers, but if you know these properties and as you look at them every day when you're doing your notes and your homework and studying, you can see how you'll get to the answer a lot quicker. And I'll show you when we get to some of those examples how that works and why that works using the properties. All right, so the directions, again, are important. Like the directions the other day when it said change all the radicals to exponential and the exponentials to radicals. Here it's saying write each in exponential form. So you're not solving, you're not evaluating, you're just writing in exponential form. So you just use your, here it says, here it's an a, so log base a of x equals y. That's the log form, which is given. We want to change it in exponential. So a to the y equals x. So 3 squared equals 9. You're not saying 9 equals 9. The answer is not 9. The answer is 3 squared equals 9. So again, just be sure you follow the directions. That one is pretty apparent that we did it right, because we all know that 3 squared is 9, so we know we wrote it correctly. If we'd said 9 squared equals 3, hopefully we know that's not true, so we did not do something right. This next one, natural log, means there's an automatic base of e, so it's going to be e to the negative 1.6. If you want to use the squigglies, you can. I do not care if you put just equals or squiggly equals. Squiggly equals just means approximate. It doesn't exactly equal that, but again, it doesn't matter to me. Either one is fine. Squiggly equals is probably a little bit more correct, but as far as that goes, that does not matter to me. And then here, log, if there's no base, it's assumed to be 10. If you need to put that there for your own sake in the work, that's fine. Just never include it in your final answer. So 10 to the 2 equals 100. So we went from log to exponential. Now we're going to go the opposite. It's given an exponential. We want to write it in logarithmic form. You're not solving, you're not doing anything, you're just rewriting it in that form. So this is the base number, which is a. So if you need to write that, a to the y equals x. If writing that underneath it helps you, then do that. You don't have to, but if it's helpful, you can do that. So our base number is 10. So that's log. We don't put the base 10. I'm going to put it there for right now and then rewrite my answer correctly in a second. Log base 10, and then the y value. So the 0 is the y value. So log base 10 of 1 equals 0. So our answer would be log of 1 equals 0. Again, in your final answer, don't ever put that 10. It's not wrong, but it's not simplified. All right, here, 25 to the 1/2 equals 5. So log base 25 of 5 is equal to 1/2. And it's going to be very important that you write your numbers kind of like in the correct size. So the log and the 5 are all the same size. The 25 is like a little exponent, but it's a superscript. So it's down, instead of being in the top right, it's in the bottom right. So be sure you write that nice and small, and that the log and the 5 kind of are all the same size. We have an e, so that means it's going to be natural log. So natural log of 6 is equal to 2x. We're not solving for x, we're following the directions. The directions say write each equation in logarithmic form. So that's what we did. All right, now we're going to evaluate. And there's a couple different ways that you can do this. Some people like to change the bases to be the same. You can do that and use your properties. Or you can, we want to know what does this equal. So I always just use a question mark. You can use a variable. You can do whatever you want, but I don't know why. I've just always used a question mark. So I want to know what does that equal. So if I use this log to exponent, I can think to myself, 2 to the what equals 32. Some of you can do that in your head and you don't have to write it down. You do not have to change it to exponential. Some of you can just look at that and figure it out. And some of you, as you do these problems, you'll be able to do them very easily. So the answer here would be 5. Log base 2 of 32 is equal to 5. Now next week, it might say log base 2 of 30. That would turn into a calculator problem. Just like everything, depending on what numbers we give you is going to determine if you need a calculator or not. All the problems you can do with or without, or most you can do with or without, it just depends on what the numbers are that we give you. 4 to the what equals 64. Again, if it's easy for you to put equals something and you want to figure that out, then do that. So we get 3. 2 to the what is equal to 1/8. Some of you can figure that out very easily. Just by looking at it, you know the answer. If you don't, okay, and it's so easy for some of you to get things mixed up, is the answer a fraction or is it negative? Okay, some of you don't know the difference between a fractional exponent versus a negative exponent. So this is where you can get the like base like we did yesterday. I need my bases to be 2. So 2 to the what equals 1 over 2 to the third. We can't just get rid of that 1 over, but we can change it using our laws from the first day. Even though we don't want negative exponents, we're not getting negative exponents. We're trying to solve for the question mark here. So 2 to the what, as long as I have like bases, I can set my exponents equal. So I can bring this to the top and change it just like I can bring it to the top to the bottom to make it positive. I can do the same thing, top to bottom, bottom to top to make it negative. So 2 to the negative 3. So now that my bases are the same, my answer is negative 3. If you can figure that out from right here, terrific. Okay, if you can't, get your like base, set your exponents equal, and you can get the answer that way. Here we have 16 to the what equals 4. And I think some of your teachers maybe did that little loop-de thing. I don't really do that, but I think I know what. Like if you start at the 16 and you do that little loop-de thing, if your teachers taught you that, okay? If that works for you, terrific. Okay, if you need to do the little loop, if you don't know what I'm talking about, I don't really use it, but I think that's what it is. So you can do the little loop-de. All right, so 16 to the what equals 4. If you don't know, then we need to get like bases. You can get a like base of a 4 or a 2. You always want to do the largest number if possible. So I can change 16 to 4 squared, but I still have that question mark, equals 4 to the what. Now that my bases are the same, 2 times what equals 1? You can just solve, and you get 1/2. 5 to the what equals 1? Anything to the 0 power equals 1. Here, base of 10 is understood. Another way, log of 1,000. Whenever you have log of 10, log of 100, log of 1,000, 10,000, a million, Michael. Anytime you have a 1 with zeros after it, however many zeros there are is going to be the answer. Okay, however many zeros there are, that's going to be the answer. So this answer is going to be 3. The reason for that is 10 to the what equals 1,000? Well, it's going to be 3. So if that was 10,000, the answer would have been 4. 100,000, the answer would be 5. A million, the answer would be 6, and so forth. Okay, that will always happen on those. And you'll see, I think log of 10 equals 1, that was one of your properties that you can remember as well. Seven to the what equals 49. So that one's easy because we know 7 squared is 49, but we're doing the same thing. We can say 7 to the what equals 7 squared. We got like bases to be 2. Obviously for that one, most of you probably don't have to do that, but that's what you're doing. For the ones that you're not so sure about, it's the same steps. It's just the numbers that you know, you can just answer immediately usually. 7 to the what equals 1 over 343. So 343 is 7 to the third. If we need like bases, 7 to the what equals 7 to the negative 3. So it is negative 3. Some of you can get that from the original problem. You don't have to show any work. You can just come up with those answers. Some of you, as you start doing these, it'll start to make more sense. You'll start to remember them. Some of you do remember them from Algebra 2. If you do, terrific. It'll be easy for you. If not, here's some more practice. Practice them and they will become very, very easy. 7 to the what equals the cube root of 7. Hey, we have an exponent and here we have a radical. So now we have to use that property from day 1, going from exponential to radical, so 7 to the power over root. So there your answer is 1/3. It is very easy to get radicals, I'm sorry, not radicals, exponents that are negative versus fractions mixed up. So if you're getting those mixed up, if you show the steps and show the work, you're less likely to get those messed up and mixed up. Okay, so know the difference between a negative exponent versus a fractional exponent. A fractional will give you a radical. A negative is going to be numerator to denominator. All right, here's where you can use some of those properties if you want. You don't have to use the properties, okay, but you can. So you can keep doing what we've been doing, but the property right here, see, natural log of e to the x equals x, e to the natural log of x, those are the properties that I'm talking about on that second page of notes. So here we have the property is natural log of e to the x equals x. So we can just say 5. Or if we kept doing what we've been doing, e to the what equals e to the 5th, we still get 5. It is up to you which one you want to use. Do you want to use going from log to exponent, exponent to log, or do you want to use the properties? You will get the same answer. If you do it correctly, either one of them will work. Same thing here. The property is log base b of b to the x equals x, as long as those base, the b's, the base right here, or the log base 5, and you're taking whatever you're taking the log of, those numbers are the same, then that expression is equal to the exponent. What we've been doing, 5 to the what equals 5 to the 7th, the answer is still 7. Completely up to you which way you want to think about that. And then again, the log of 10 is just going to be 1, or you can think 10 to the what equals 10. 10 to the first equals 10 to the first, so that's equal to 1. Most of you will see these log of 10, 100, 1,000. You'll see that so much, you'll start to just know what it is. Natural log of e, that's another one of those properties. It's just equal to 1. When we get into the word problems, anytime there's an e involved, it's automatically going to be a natural log. Okay, so anytime there's an e, you're going to use natural log versus log. Natural log is something you use a lot more in calculus, so just being familiar with that. The log and the natural log properties are the same. It's just a different prefix out in front of there, log versus natural log. Logs can have any kind of base. Natural logs can't. Natural logs only have a base of e. If you wanted to do this one the way we've been doing it, e to the what equals e, you get 1. This one's kind of poorly typed, so this is what it should look like, is something more like that. Okay? So 2 raised to the. Again, the typing, the way that it got typed, just didn't look very good. So it is the property b raised to the log base b of x is equal to x. So as long as this big base and this little base are the same, then it's equal to whatever you're taking the log of. If those bases aren't the same, that's not a problem we didn't even give you. The reason we give you this problem to see if you recognize that property. Okay, that's all that would do. Same thing for here. This e just means it's a natural log. So these are really the same properties. Logs can have any bases. Natural logs only have a base of e. So that answer is root 5. So your homework today looks kind of long, but some of them are this easy. Like you're going to go through 10 of them in a minute, okay, if you use those properties. A couple more. 32 to the what equals 8. So one you probably can't just look at and figure out. A few of you maybe, but most of you probably can't just look at that and figure out what that is. If it was the other way around, maybe. So like bases. 2 to the 5th to the what equals 2 to the 3rd. Anytime what you're looking for is in the exponent, so the missing letter, the missing variable, the missing value is in the exponent, that's when you want to get like bases. If you don't have a calculator and whatever you're looking for is an exponent, that's when you want to get like bases. So since we have like bases, we can set those equal to each other. 5 times what equals 3? Divide by 5, and we get our answer, 3/5. So again, not one you probably can just figure out by the top, on the top of your head. You might need to show a couple steps for that. Same thing for letter Q. 4 to the what equals the square root of 2. So this we can say 2 squared, and this one we can get rid of the radical using that property from day 1. Power is 1, root is 2, 2 to the 1/2. Square root, same as raising something to the 1/2. And then we can say 2 times what equals 1/2. Divide by 2. Now, I cannot tell you how many times I have people write this and then tell me the answer is wrong because they divide by 2, and then over here they say 1/2 times 2 because they just changed divide to 2. You can change divide to multiply, but only if you multiply by the reciprocal. So 1/2 divided by 2 is not the same as 1/2 times 2. If you have $100, if I say here's $100, I'm going to double it versus I'm going to cut it in half, that's a big difference. Okay? So we can change that to multiply, but only if we multiply by the reciprocal. So 1/4. That can be very easy to get correct if you show your work. Okay? Not that you get any credit for showing work, it's just helpful to you. The reason we harp on you to show your work is because if you show your work, typically you make less mistakes. The less work you show, some of you, the majority of you, will make careless mistakes if you don't show your work. Those of you that always show your work very seldom make careless mistakes. And again, there are plenty of you that can do these things in your head, but most of you cannot. You make careless mistakes when you don't show those steps. All right, and then what this is just telling you that you can't find out necessarily exactly what these are equal to, but knowing your properties and laws, you can figure out about what they're equal to. and then arrange them from least to greatest. So we don't know what log of 101 is. But 10 to the what equals 101? We know that 10 squared equals 100, so it's going to be 2 point something. We can figure out that it's a little bit more than 2. We have enough information, we've learned enough to be able to do a problem like this. E to the what equals 1 over e. So e to the what equals e to the negative 1. So this one's equal to negative 1. We know that exactly. 9 to the what equals 3. 3 squared to the what equals 3 to the first. So 2 times what equals 1. We know that's exactly 1/2. 3 to the what equals 31. Can we figure out exactly what that is? No, but we have to use some of our mathematical sense. We know that 3 cubed is 27. We know that 3 to the 4th is 81. So we know this one is going to be 3 something. So now we can arrange them from least to greatest. So here's the first one. That's the least. Then we have 1/2. There's the second one. Then we have 2. That's third in line. And then the greatest would be 4. So even if you got to use a little bit of your brain on problems like that, even if you don't know exactly what it equals, doesn't mean you can't do it. Doesn't mean you need a calculator. If I had said, what is log base 3 of 31? Now that would be something that you can't do. You don't have enough information to do that, or you don't have a calculator. But if I'm asking you to arrange something, what's greater than, less than, whatever, then yes, that is a skill that you could do. And then again, here are just these properties for you to know, look at. The more you look at them, the longer you look at them, the easier they'll be to remember.